All right, so I'm here to talk today about the product rule in calculus. So if you've got a function which can be broken into two unique parts that are being multiplied, right? So f of x times g of x, the derivative of that product will be the derivative of f of x times g of x plus f of x times the derivative of g of x. That is really complicated. I can't remember it. I remember it like this: f prime g plus fg prime. Okay? Where the first function is f and the second function is g. Okay? So what I want to do is show you a few examples of how this works. And the first example I always show one of my classes is I show them a problem that we could do without the product rule to prove that it works. Okay? So I'm going to take a particular function here, and we're going to say take the derivative of 3x times x squared plus 2x minus 4. Okay? Now, with the product rule, the way we would do this is this would be f, and this would be g. And our derivative will be f prime g plus f g prime. So the derivative of the first times the second plus the first times the derivative of the second. Okay? So f prime is 3. G is literally just copying that function. So x squared plus 2x minus 4 plus f is copying that function, 3x, times g prime, which is the derivative of this part. Okay? Well, the derivative of x squared is 2x, and the derivative of 2x is 2, and the derivative of constant is 0. So we stop. Okay? Now we have to combine like terms. Okay? So to do that, we're going to distribute here, and we're going to distribute here. So if I distribute here, I'm going to get 3x squared plus 6x, keep breaking my pencil lid today, plus 6x minus 12. And then if I distribute here, right, 3 and 2 makes 6x squared, and that's going to be plus 6x. Now, combine like terms, we'll get our final answer. So 3x squared and 6x squared makes 9x squared, right? Scoot this up so you can actually see it. And then 6x and 6x makes 12x and then minus 12. Okay? And that's our final answer. Now, what if I did this without the product rule? Okay? What I mean is go ahead and multiply these first and then just use the polynomial rule. So if I multiply those first, which I'm allowed to do, 3x times x squared is 3x cubed, and 3x times 2x is 6x squared, and 3x times negative 4 is negative 12x. Now, use the polynomial rule and take the derivative of these three terms. Well, here you're going to say 3 times 3 is 9, and reduce that by power of 1. So you get 9x squared. Here you're going to say 6 times 2 is 12. Reduce that by a power of 1. So you get plus 12x. And for some reason, some students have the most trouble with this one, but I'm going to walk you through it. Remember, that's a 1. So you're going to say this guy times 1. All right, well, negative 12 times 1 is negative 12. And you're going to reduce this by a power of 1, which is x to the 0. And somewhere off to the side here, I'm just going to remind you to remember that x to the 0 is equal to 1. Okay, x to the 0 is equal to 1. So you get negative 12 times 1, which just gives us negative 12. Okay, so we get the same answer. As a matter of fact, if you are given this problem, you should not use the product rule because it is easier to multiply these than it is to simplify that. Okay, but I like to do my first example with 1 so you can see we get the same answer. The product rule is typically used on things we cannot multiply. So let me give you a good example of that. If I ask you to find d dx of square root of x times x cubed minus 7x. Okay? So, because of this square root, this is not something you could readily distribute to those guys. And so we would use the product rule. Okay? And whenever we use the product rule, we always want to go in and label our two functions, right? So this is our first function, f. And this is our second function, g. And I always write my rule. Okay? So my rule is this derivative is going to be equal to f prime g plus f g prime. Okay? And you can write multiplication in there if you choose, or you can just write them next to each other and know that it implies multiplication. That's a personal preference. But long story short, guys, you got to make sure that you know your two functions and you know you can find the derivative of those two functions. So with that said, my pencil ran out of lead while I was talking. That's my luck. So let's go ahead and do this. So f prime, right? So the derivative of square root of x. Now, if you've never seen this, I'm going to come off to the side and do it as kind of what I like to call side work in my classes, okay? But this is one you should memorize because you run across it so much, okay? So I'm going to show you how to get this. So I'm going to rewrite this as x to the 1/2, x to the 1/2 power. And I'm going to take the derivative of that, okay? Take the derivative of that. And the way we do that is we multiply the power by the coefficient, so we get 1/2, and then we subtract 1, which is going to give us x to the negative 1/2. Well, that is going to be square root of x moved to the bottom. And so that's going to give me 1 over 2 root x. Okay, 1 over 2 root x. And I've just got it memorized. Whenever you take the derivative of square root of x, it's 1 over 2 root x. Okay, 1 over 2 root x. So, for f prime, I'm literally going to write 1 over 2 root x times, and then for g, I'm just going to copy. Right? So I get x cubed minus 7x. Right? And then plus, and for f, I'm going to write square root of x times, and then g prime, well, you got a 1 here. 3 times 1 is 3, right? And then reduce that exponent by 1. And then negative 7x, that'll just be negative 7. It'll be the derivative of g. And then we try to combine these any way that we can. Okay, we try to combine these any way that we can. Unfortunately, there's really no way to combine these, and so that would be our final answer. Okay, bam, product rule. Okay, let me give you a different one. One that I think is a little more kind of with how you would use this. Okay, so let's say we've got 3x to the 5th plus 7x squared times x to the 4th minus 3x squared plus 11. Okay? And we've been asked to find the derivative of this. Now again, you could multiply these two. That's going to be a lot of trouble. So instead we're going to use the product rule. Okay? Product rule. And we use the product rule a lot more later in calculus when you know some other derivatives. But right now, for an introduction to this, this is how we use it. Okay? So, again, we're going to label our functions. This will be f, and this will be g. Right? F and g. And I'm always going to write my rule, f prime g plus f g prime. Okay? Cool. Find his derivative. Well, 3 times 5 is 15. Reduce him by 1. You get 15x to the 4th. And then 7 times 2 is 14. Reduce him by 1. you get 14x. That is f prime. Now we got to write g, copy. Okay, so it's just literally copy this. X to the fourth minus 3x squared plus 11. Okay, plus, and we're going to come down here. F is literally just copy that. 3x to the fifth plus 7x squared times, and then g prime. And g prime, right, 4 times 1. Reduce that by 1, so you get x cubed. 3 times 2 will be minus 6. Reduce that by 1, so you get x to the first. And the derivative of a constant is 0. So we stop there. And someone's always going to say to me, do you have to write the 1? Nah, you can if you choose to. You don't have to, okay? And so that would be our derivative at this early stage in a calculus class. In one of my later videos, this is going to come up again, and I'll show you how you use it when you know some more derivatives. So if you have questions about the product rule, leave them in the comments, and I hope it helps somebody. All right, so I'm here today to talk about the quotient rule in calculus. So in most textbooks, you'll see the derivative of f of x over g of x, right? So there's some rational function that has a numerator and a denominator that are both powers of x, okay? Some power of x. Could be x, x squared, x cubed, some polynomial form. It could be e to the x. It could be sine x, right? It could be all sorts of things. But for just basics here, the quotient rule, we're going to have some form of a function on top and some form of a function on bottom. And if you copy this right out of most textbooks, it'll say f of x over g of x. The derivative of that's equal to f prime of x times g of x minus f of x times g prime of x over g of x squared. I hate this notation. I can't remember it. So let me tell you how I remember it. So how I remember the quotient rule is I use the letter N and the letter D. N is for numerator, D is for denominator. The derivative of a fraction with a numerator and denominator, for me, is equal to N prime D minus N D prime over D squared. Okay, that's how I remember the quotient rule. And it works really well for me. Okay, so whenever I see the quotient rule, this is what I'm going to write. Okay, so I want to give you a couple of examples with these. See if I can help you out a little bit. So here goes. Let's start with something simple. So let's find the derivative. And again, these will all be polynomial examples because usually this comes really early in the class. Later on, I'm going to do some more advanced examples that will use the quotient rule. So, all right. So we've got x squared plus 3x minus 5 over x squared plus 9. Okay? So, the derivative of this guy. Fair enough? And really simply, we know this is our numerator and we know this is our denominator. And so we can follow this formula very, very, very easily. So I'm always going to write my formula, n prime d minus n d prime over d squared. And I urge you, if you are having trouble with math or physics or engineering, the first thing you should always do is write the formula you're using. Write the rule or the law or the theorem that you're using. Don't just start plugging in numbers. It's really helpful to you, and it's also really helpful for your teacher to see where you went wrong. Okay, so I know you know to use the quotient rule when you write that. Now, we're going to go in steps. What is n prime, right? The derivative of this numerator, right? So that'll be 2x plus 3. That's n prime, right? D, just copy, x squared plus 9. Minus n, just copy, times d prime, okay? Well, times 2, lower that by 1, we get 2x, and the derivative of 9 is 0, okay? And that's going to be over d squared. So that's going to be over x squared plus 9 squared. And unless unless we see an x squared plus 9 that we can factor out of both of these or something like that. We leave this denominator in that form usually because there's just a very rare chance that you would need to expand that. So we typically leave it in that form. So you'll see it that way, at least in my class. But really in most of your calculus texts, they leave that denominator in unexpanded form. Now, before you can call this finished, you have to try and combine these two guys, or you have to try and factor out anything that they have in common, okay? So I'm going to start this real easily. Let's go this guy. I'm going to just distribute this 2x, right? So 2x times x squared is going to be 2x cubed. And then 3x and 2x is going to be, right, 6x squared. And then 5 and 2 will be minus 10x, okay? And that'll have a nice big minus sign in front of it, right? The bottom we're going to leave as x squared plus 9 squared. And we're not going to do anything with that. And then here we're going to multiply this binomial, okay, times this binomial. So I'm going to use the FOIL method, first outer, inner, last, right? So first will be 2x cubed, and that'll be 18x. So I'm going to put that here, plus 18x. And then 3 times x squared is going to be 3x squared. And then 3 times 9 will be plus 27. Right? So that'll be that guy. And now we're going to put these together. Okay? So 2x cubed minus 2x cubed, those will cancel out. Okay? And then I've got 3x squared minus 6x squared. So that'll be negative 3x squared, right? 18x minus negative 10x. That's going to be 18 plus 10. So that's be plus 28x. And then the plus 27, we're not doing anything to him. So over x squared plus 9 squared. And that would be our final answer for this quotient problem. Okay? So that'd be our final answer. So that's using the quotient rule. Now, later on, the quotient rule will get more complicated, but this kind of early on in calculus, when you learn the quotient rule, they're typically going to be with polynomials. Occasionally, it will be with like a radical. And that's going to be my next example, is going to be with a radical. So kind of show you that. So here we've got d dx of, and let's take x cubed minus 3x squared plus 7 over the square root of x. Okay? Cool. So that's we've been asked to find this derivative. And we know we're going to use this formula, right? Here's our numerator. There's n, and there's d, right? There's n, there's d. So what do we get? We're going to get a fun problem is what we're going to get. But anyway, let's go ahead with it. So we get n prime d minus n d prime over d squared, okay? And we're going to follow that formula to a T. So, n prime, I'll come over here a little bit, is going to be the derivative of that. That'll be 3x squared. Okay, so 3x squared. And then this will be 2 times 3, so minus 6x. And the derivative of 7 will be 0. Okay, so that times d. Well, d is just square root of x. Okay? Minus n d prime, okay, so minus n, just copy, d prime, okay, d prime. Now, in my product rule video, I wrote this little fact, and I'm going to write it on here again. The derivative of the square root of x. You should memorize it because it comes up so much in calculus 1, 2, and 3. The derivative of square root of x is 1 over 2 root x. 1 over 2 root x. So I'm going to put 1 over 2 root x. Okay? Over, Now, d squared. Well, square root of x squared is just x. Okay? It's just x. All right? So, with this, the only thing you can do is really try to make it prettier. Okay? So what I'm going to do is I'm actually going to break this into two fractions. I'm going to break this into two fractions and show you what it looks like. So this first piece is going to be that over x, right? So it'll be 3x squared minus 6x root x over x. Okay? Minus, and then we'll take this guy, right? It's going to be x cubed minus 3x squared plus 7 over, and we're going to take, right, it's going to be over x and that, because it's times 1 over 2 root x. So it's going to be x 2 root x. Okay, so 2x root x is what we get. Okay, and then the only other thing we can do is see if there's a way to simplify either of these fractions. Okay, so 2 will not go into all of these. X will not go into all of these because of the 7. And of course, the square root of x, there's nothing you can do with him. So this guy's good. This guy, however, if you notice, you have an x here and an x here. And so what you can actually do is you can rewrite this. So I'm going to come off to the side here. I'm just going to bring this off to the side. I can rewrite this as x 3x minus 6 root x over x. Okay, so what I've done is I've factored an x out, and so I've got a times b times c over x. And because I have multiplication here and here, and this is division, multiplication and division are inverses, and so I've got x times blah 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 divided by x. And so I really end up with what? X over x. And that's 1. So this becomes, right, these, we like to say they cancel out. That's not really true. They become 1. Okay? But that x over x becomes a 1. And so we get 3x minus 6 root x minus x cubed minus 3x squared plus 7 over 2x root x. Okay? And that would be a simplified, the paper wants to slide on me. That would be a simplified quotient rule problem. Okay? So these are messy and they're ugly sometimes, but the big deal is not getting this pretty. The big deal is, can you get from here to this step here? That's the biggest part, because you found the derivative. Everything else is just really making the answer look pretty. So if you have questions, ask them. I hope that helps. Leave them in the comments if you have questions. If you have other videos you want to see, let me know and I'll try to do them.